Hello, everybody. Hopefully, you all are having an amazing day, and hopefully, I can just make it a little bit better by helping you understand the concept of predicting products of reactions. So, before we start, we need to make sure we understand the 5 main reaction types, which were covered in a separate video, but I'm just going to go through them each one by one very briefly. So, for the first reaction, we have a formation reaction, or what's better known as a synthesis reaction. Now, this reaction proceeds in a very simple general pattern of this, where it's going to be A plus B into AB. Now, so that's the first one. We have a second one, which is a decomposition reaction. Now, the decomposition reaction is basically the complete opposite of a formation/synthesis reaction, as it just breaks down into two separate parts like so. The third one is called a single replacement reaction, but I'm just going to shorten it so I don't have to write it all out. A single replacement reaction looks a little bit like this. Next, there is a double replacement reaction, which looks a little bit like this. See there. Goes into Okay, so that's the 4 that we really need to know. There is also a 5th one, which is just a combustion reaction, where the X and Y can be any kind of number. CO2 plus H2. This is a combustion. Okay, so the big idea for predicting products of reactions that come from these reaction equations is we do not want to start trying random combinations. Instead, we want to ask ourselves one question: what type of reaction this is? Because once you know the reaction type, the product follows a predictable pattern. So we'll outline a very quick strategy / step-by-step pattern so all of you can really hone in on all of this. So step 1 is we really want to identify the reaction type. Now, the reaction type is the 5 that we just listed. So reaction type. Now, once you've done that, we can move on to step 2, which is we need to rearrange the elements or compounds based on the reaction pattern. Now, step 3 is we really want to write the correct chemical formulas using ion charges if needed. So what I mean by that is using like Na plus Cl minus, okay? So once we use the correct ion charges, it's very smart to use those in balancing the reactions especially, and also just writing it out so you help yourself understand it a little bit better. So, right. Correct. With ion charges. Okay, now we have that, we want to move on to step 4, which is checking if the reaction actually happens. So that's step 4. And then the final step is to balance. Basically, that is a very quick step-by-step pattern / strategy that we can all use when we want to predict a certain product. Now that we've gone through every single kind of reaction type, and there is a more in-depth video on my channel that you can go check out. Now that we've outlined a very brief step-by-step outline / strategy, we're going to put it all together and go through each one of the steps very in-depth to make sure everybody is on the right page. So step one, if we all remember, is to look at the reactants. Okay, so we want to ask ourselves a couple questions, okay? So the first one is, are there two elements combining? Now, I'm sure everybody should know what that means is it's a synthesis or formation reaction when two elements are combining, okay? So if it is, we already outlined our reaction equation and the reaction that we're actually using. But if it's not, we want to ask ourselves the second question, and that's basically, is a compound breaking apart? Now, if a compound is breaking apart, that means it is a decomposition reaction. But let's say if we're looking at a reaction and it doesn't follow any of these two rules, we're going to go on to the third one. Now, is there an element reacting with a compound? So if we have an element reacting with a compound, that is what's known as a single replacement. I'm just going to say form synth on this guy. Syn decomp. So if there's an element reacting with a compound, it is a single replacement reaction. But let's say we're looking at a reaction and it doesn't follow any of these rules at all. We're going to ask ourselves one of the final questions, and that's two compounds reacting. Now, if it's two compounds reacting, this is a double replacement. Now, again, if we don't follow any of these rules, there is one more, and that one is the combustion reaction, which is, that rule is the hydrocarbons. So if we have a hydrocarbon reacting with oxygen, where it's that C₃H₈ plus O2, this is a combustion reaction. Okay, so now that we've outlined all the rules and we're finally into the next step, let's say we found a reaction that's working for us. We want to move on to the next step. Now, step 2 is going to be using said reaction pattern. Okay, so what we mean by using the reaction pattern, it's just the 5 reaction patterns that we were just talking about. So let's say, so for step 2, we have the reaction patterns Again, all of them have been outlined before in a separate video, but we have the synthesis, we have our decomposition, single replacement, double replacement, and combustion. So once we found the one that's actually worked for us, we can proceed on to step number 3, which is the correct formula. So this is where ion charges really matter, okay? So for example, we are going to use calcium and chlorine to form calcium chloride, okay? So Ca and Cl form calcium chloride, which is CaCl2. But the ionic charges matter in this case. So the ionic charges for calcium and chlorine are as follows, okay? And this is something we will go into very in depth in a separate video that we covered on my channel much later. So the formula is CaCl2. So always make sure the charges balance and check if the reaction actually happens, which is going to be our 4th step. Check to see if the reaction happens. So for a single replacement, we want to use the activity series. And for a double replacement, check for a precipitate, gas, or water being formed, because that is when we'll know it is a double replacement reaction, okay? So once we've figured that all out, we are able to move on to step 5, which is the final balancing step. So step 5, balance. Never change the subscripts to balance, only change the coefficients. That is a rule that was heavily covered in another one of my videos on my channel. Let's do a practice problem. We're going to try aluminum, CuSO₄, into what? I want everybody to pause the video and come back once we are ready. Okay, hopefully you guys have all tried this problem out and have gotten an answer. So let's walk it through step by step. So we have a element. We also have a compound, which is going to be forming something. Now, when an element is reacting with a compound, we know it's going to be a single replacement reaction. So it is an SR reaction because it is a element plus a compound. Okay, aluminum is trying to replace the copper. So aluminum is more reactive than copper, so the reaction is going to happen. So Al plus CuSO₄ is going to create Al2SO₄, 3. So aluminum sulfate will be formed, and the only thing that's going to be kicked out is the copper. So the unbalanced equation looks to something like that, is written on the screen. Now, the last thing we really need to do is we really need to balance it, okay? So looking at this reaction equation, I noticed that we need 2 aluminums to balance out the product and reactant side. So next that we have the 2 aluminums, we also need to look at the sulfate groups. So I'm looking at that, and it looks like we only have 1 sulfate group with the copper sulfate, and the aluminum sulfate has 3 sulfate groups. So we're going to add a coefficient of 3 right here. And the final thing that we need to do is add a coefficient of 3 on the copper, since we did add a coefficient of 3 at the copper sulfate. So this is our final answer right here. So hopefully you guys all got that practice question right. Let's try another practice problem. I want everybody to predict the products of the following reaction. Pause the video, take some time, and come back when you have an answer. So hopefully you guys took a moment to pause this video and find an answer that works. So we're going to walk through it step by step. So we have two ionic compounds reacting with each other. So when two ionic compounds react with each other, it is what's known as a double placement reaction. Okay, so the cations are going to switch anions. So for this reaction, the things that are going to swap is the Ag is going to really want to pair with this chlorine, and then this K, this potassium, is going to want to pair with the nitrate. So the products of this reaction equation are going to be as follows. Boom. Now, looking at this equation, one of our fifth and final steps is balancing. But I want everybody to take a look at this reaction and tell me if there's anything that's actually unbalanced. There isn't. Everything is already balanced. So we need to really check if this reaction actually happens. So what I mean by that is, because double replacement will only happen if a solid is kind of formed. A solid, a precipitate, a gas, a liquid. So AgSO₄, or you know what, I might just write the states under it so I don't have to write it all again. Silver nitrate is an aqueous species. The KCl is also another aqueous species. Now AgCl is a type of salt, and potassium nitrate is also a aqueous compound. So because AgCl is a solid, this is a double replacement reaction. So hopefully you guys all got that correct. Let us try another one. Okay. I want everybody to predict the following products for this reaction. Take a moment, pause the video, come back when you have an answer. Okay, so hopefully everybody took some time and came up with an answer that's working. So let's walk this through step by step. We have a hydrocarbon, and we also have oxygen. This is a combustion reaction because a hydrocarbon is reacting with oxygen. So the products are really not going to change. They're going to stay the same as CO2. What the hell? CO2 and H2O. So let's write this out really quick. So we have C₃H₈ plus O2 to CO2 and H2O. Okay. Finally, we also need to balance this equation because it is unbalanced. So I'm going to look, and I'm going to start with our C's because the carbons are unbalanced. So we have 3 on the reactant side, 3 on the product side. So let's put a 3 there. Now let's come back to our oxygens on the reactant side, since I just added a coefficient to the CO2, which has six oxygens now. What I'm gonna have to do is I'm gonna have to put a coefficient right here. Okay. Actually, that is not gonna work. We're gonna have to put a 4 on the H2O. And now finally, there we go. I figured it out. Put a 5 right here. Okay. Real quick, we can break this down. We have 10 oxygens. We have 3 carbons. We have 8 hydrogens on the reactant side. 3 carbons. There are 4 oxygens on that guy. There are 6 oxygens on that guy. And then there's 8 hydrogens. This is a balanced equation. So hopefully you guys all got that correct. Now, there are a couple common mistakes that a lot of people make, okay? So first, they balance before actually predicting the correct products. So what I mean by that is if we had let's say we had the C₃H₈ and the O2 on the reactant side. Even though there isn't nothing to balance, a very common prediction, and it doesn't just apply to these kinds of reactions, it applies to every single one as well, where people just predict what the coefficients will be without actually knowing what the products are like. Don't do that. Predict the products first, then balance. Second, they also forget the ionic charges. So the ionic charges are very important, like the Ca and the Cl, which forms the CaCl2. For ionic compound, you cannot just stick symbols together randomly, okay? So this is one example. We also have another example of AlO, aluminum oxide. Al has ionic charge of 3+, and O has an ionic charge of 2-. Now, aluminum oxide isn't this. It's actually this. Third, people also change the subscripts while balancing. That is a huge rule that I very much enforce in my last video and also this video. Do not change the subscripts, only change the coefficients when you're balancing an equation. Fourth and the final mistake is, and this only matters especially for single replacement and double replacement reactions. They actually forget to check if the reaction actually happens. And that's what I mean by we also have to look at the activity series for a single replacement reaction. We also need to look if a gas, a solid, like a precipitate, or a liquid is forming. That is the only rules that apply when a double replacement reaction is happening. Finally, a very quick final summary to end off this video to predict products of a chemical reaction. So always identify the reaction type. Once you have that, use the pattern. Use the pattern. Write the correct formula. Check to see if the reaction actually happens. And then finally, balance the equation. The more you practice, the faster this will become, and eventually you will look at the reactants and instantly recognize the pattern. So that is how you predict products of a chemical reaction step by step. If this helped, like the video, subscribe, and comment what topic you want next. Hopefully you guys have all enjoyed this general chemistry video, and I will see you guys in the next lesson.